Okay, so we're going to be focusing on how to find double-sided limits using L'Hopital's rule. Alright, so the instructions are for us to evaluate the limits. So number one, let's say we were to look for the limit as h approaches 0 of 1 over 2 plus h raised to the fifth power minus 1/2 raised to the fifth power, all this divided by h. Now, how do we know that this is a double-sided limit? This is a double-sided limit because the number that h is approaching does not have a sign. Okay? So if it does not have a sign, what that means is there's an invisible plus and minus there. You're approaching 0 from both directions. So keep that in mind. Whenever the direction is not specified, it is automatically double-sided. You're going from the left and right. We're going to substitute first whenever we're looking for finite limits. So substitute first. So we substitute, we're going to have 1 over 2 plus 0 raised to the fifth power minus 1/2 raised to the fifth power divided by 0. So since the denominator is 0, this expression is either indeterminate or undefined. What will help us to determine if it's indeterminate or undefined is by simplifying the numerator. Okay? If we simplify the numerator, we have 1/2 raised to the fifth power minus 1/2 raised to the fifth power divided by 0. We're subtracting identical numbers on the top, so we're going to have 0 over 0. 0 over 0 is known as the indeterminate form. So that means we cannot figure out the limit using this form that we have right here. We have to carry out some kind of transformation, either using algebra or calculus, and then try and find the limit again. Alright, so we're going to use L'Hopital's rule to transform the problem. So use L'Hopital's rule. So all we're going to do is just find the derivative of the numerator and the numerator and take the limit again. Alright, so we have the limit as h approaches 0. We have 1 over 2 plus h raised to the fifth power minus 1/2 raised to the fifth power. So what L'Hopital's rule says is that if you get an indeterminate form when finding the limit of a rational expression, the result is the same thing as finding the limit of the derivative of the numerator and the denominator. So we're going to differentiate the numerator and the denominator. Note, we are differentiating them separately. This is not the quotient rule. This is called L'Hopital's rule. Okay? So all we're going to do now is differentiate every single one of them one by one, put it back here, and find the limit. Here. So what we're going to do now is focus our attention on this first term right here, 1 over 2 plus h to the fifth prime. What's the derivative of this? It's raised to the fifth power. We're trying to find the derivative. Now, since this is a composite function, we're going to make use of the chain rule. Okay? So what we're going to do is take out the outer function. F of x is x to the fifth. And then we take out the inner function. G of x is 1/2. Well, our variables is h in this case, so let's just use h as our variables. So h is, so f of h and g of h. still the same thing. So we have f of h is h to the fifth, and then g of h is 1 over 2 plus h. Alright, so after decomposing the function, what we'll do next is we will differentiate both of them. So the derivative of h to the fifth. Alright, so the derivative of h to the fifth is 5h to the fourth. The derivative of g of h, g prime of h, derivative of 1/2 is 0. The derivative of h, since it's to the first power, all we do is we take the coefficient of h, which is just 1. Alright? Now, the derivative of the outer, evaluated at the inner, we're going to multiply that by the derivative of the inner. Okay? So the derivative of this function here is going to be 5. Instead of h, you plug in what g of h is. So 5 times 1 over 2 plus h raised to the fourth power times 1. And that's the derivative of the first term in the numerator, the quantity to the left. Okay, and then let's go to the next one. 1 over 2 raised to the fifth power. We'll have to find that derivative too. Since 1 over 2 raised to the fifth power is a constant, its derivative is simply going to be 0. What you want to note here is we're differentiating with respect to h. H is a variable in this problem. And then when we differentiate the denominator, derivative of h is simply going to be 1. Derivative of h with respect to h. Okay, and then we can plug everything back into the original problem. So we have the limit as h approaches 0 of 5 times 1/2 plus h raised to the fourth power. This part is 0, this part is 1. So all we are left with is just the numerator. Okay, so what we'll do next is we're now going to substitute again and hope that the limit works out. If we have an indeterminate form, we just differentiate again and go on from there. Alright, so if we substitute, we're going to have 5 times 1/2 raised to the fourth power, which is going to be 5 times 1 to the fourth is 1, and 2 to the fourth is the same thing as 4 squared, which is 16. Your final answer is 5 over 16. Okay, so there you have it.